Hello and welcome to lesson 1.1, functions. Today we're going to talk about how to actually determine what a function is, what a function looks like, how you can look at its domain and range, and various different aspects of functions. So most of this should hopefully be reviewed from the course Functions, grade 11, but let's go over it. So a function is a relation in which there is only one y value for every x value. That is, x values cannot repeat for different y values. So there are two main ways to determine if a relation is a function. If you look at it graphically, use the vertical line test and verify that the line will cross at most one point. If you're doing it numerically, examine the ordered pairs or table values and make sure there is only one y value for every x value. Now please recall the term domain and range. Just domain looks at a list of all the x values that you could possibly have for your expression, and the term range is just a list of y values for your relation. Okay, so let's take a look. Here we have a few different relations, and we're going to determine whether or not these are functions. We're also going to look at determining the domain and range for each of these relations that we have here. So our first one, take a look at this this relation, and see what it looks like. We have this red line that goes up and gets very large as it approaches x equal to 0 from both sides. It goes towards positive infinity and negative infinity, and seems to cross the x-axis at maybe a value just less than greater than negative 2 and less than positive 2. Doesn't seem like there's any values defined when x is equal to 0. So it looks like the domain for this function, I'm going to use the letter D to represent domain. The domain of this function is all x values that belong to the real numbers. However, the only thing that x cannot be is the value 0. Now for the range for this item, it looks like it crosses the axis and continues up and through the expression. And it looks like all y values are chosen, and there's no holes or spaces or breaks, so it looks like the real range is all real numbers for this expression. And this would be the domain and range. Now we can also test to see if this is a function by drawing some vertical lines. Now I don't have a ruler for this iPad, so I'm just drawing it as freehand as possible. I'm just drawing a number of various different lines right here. And you can see that in each instance, it crosses exactly one point. And I can keep drawing these, but you're going to see that it happens no matter what. So this is a function. Okay, so let's take a look at part B, the expression that we have there. The expression that we have there, the relation, looks like it's a square root function, and my best guess is it continues on in this direction, so I'm drawing that blue arrow to show that it continues. Looks like it starts right at that. So it kind of looks like a square root function that has undergone some transformations. So most likely its domain for this would be, again, all real numbers for the values of x. But it looks like x starts at the value of, 2. So it looks like it starts at the value 2, and its values are 2 greater than, but not only greater than, but it is also equal to that value. For the range you can see, well, y belongs to all real numbers. Again, there's no holes or breaks that I can see, but it just doesn't exist anything below the value of 0, so y is greater than or equal to 0. And because it starts at 0, you can include it. Again, I can draw some vertical lines to draw through this to see if it's a function. I'm going to draw a number of them. and you can see it crosses at most 1 point each time. So this is also a function. Okay, so let's look at this part C question. Well, if I was to create a table of values for this stuff, looking at what I have here, let's call the input x and let's call the output y. So the x values, we have 0 and -2. We also have the 0 and 1. We also have the 1 and 2. We have the 2 and 1. And we have the 3 and 4. So these are points on the expression. Well, what you can notice is, first of all, these are all x values, and we only have specific x values. So what you can do is to write your domain. You can write your domain just by listing the x values. Oops. So you can just list the x values. In this case, 0, 1, 2, and 3. Usually you write them in numerical order. Another option is you can either describe this as the x values that are, in this case, whole numbers, or natural numbers, or integers. So you can use integers, let's say, such that the values of x are only between 0 and 3. That's one way you can describe the domain. The range, however, you can express. I'm going to choose the easier of the two methods, which is just list the numbers. So -2, 1, 2, and 4. Those are all the numbers that are there. Now to determine whether or not this is a function. So to determine if this is a function, you notice that these two values right here, these two x values, have different y values. Because there are two different y values for one given x value, this is not a function. Now another method to listing domain and range that we're going to see. Now, whenever you're dealing with real numbers, and you're dealing most of the time with real numbers, so part C, you can't write this style for part C. You'd have to write it specifically, again, as d equals 0, 1, 2, and 3, and -2, 1, 2, and 4 for the range. But if you're dealing with real numbers, then what you can do is you can just list the range of real numbers based on using circular brackets, square brackets, and going from smallest value to largest value. So let me show you an example. So for the domain, instead, for the first one, you can list it as, I have all the x values from -infinity up to the value 0. So what you do is you write an open bracket, -infinity up to 0, and the circular bracket, comma, or a union symbol, and 0, comma, to infinity. So this tells you you can choose all numbers between -infinity to 0, and then 0 to infinity. Whereas the range would have been from just -infinity to infinity. So this first style of notation that we have here is called set builder notation. The second one is called interval notation. Both are acceptable to use in advanced functions. You can choose either one. So let's show you how you can write part B using this interval notation. So for the domain, because you can start at the value 2 and include 2, you'd actually use a square bracket in that case. And largest value, you can keep going. You can just keep going up to infinity, so up to infinity. That one you can never reach, so that one's always a circular bracket. Range, similar way, so that would be 0, comma, infinity, circular bracket. And there we go. That's domain and range, and whether or not these are functions. So let's move on. Oh, looks like we've completed our lesson. So this concludes lesson 1.1.